Hello everyone. The title of this presentation is Single Nucleotide Polymorphisms Detection and the Kemp Ridley Genome. My name is Xochitl de la Rosa. I'm professor in the Centro de Biotecnología Genómica, Instituto Politécnico Nacional, and also participate Dr. Luis Hurtado and Mariana Mateos, professors in Texas A&M University. Today, I want to share with you this work about the Kemp Ridley. This species is the smallest of the 7 sea turtles and is a critically endangered species. Every year, more than 80% of adult females and males come to Rancho Nuevo for breeding, and the females nest in the sandy beaches of Tamaulipas, Veracruz, and Texas. So, this species has been threatened for many years in different times in the past and also in the present. So we know the importance that is to know about the genetic diversity and the genomic diversity of this species. We basically follow two different pipelines. The first one was identify SNPs to quantify the genomic variation of this species using the ddRAD-seq, and the second one was use the whole genome resequencing strategy. We analyzed 96 samples with the ddRAD-seq and 28 samples with the whole genome resequencing method. We filter all our raw data, and we basically follow stacks for ddRAD-seq, and for the whole genome resequencing samples, we map the reads with bow tie, and we use the two genomes in this species, the nuclear and the mitochondrial. After that, we identify SNPs, and with the mitochondrial, we assemble the whole mitochondrial genomes. What we found in this study was a very low number of SNPs. We discard actually the de novo study, and we use the analysis with the reference genome. We found about 12,867 SNPs in 80% of the individuals. But also we observe variation between plates. The two data sets correspond to two different runs in Illumina. So in the second data set, we found just 2,369 SNPs. This variation was corroborated with the resequencing genomes, at least two of them. We found that the whole genome shares some SNPs with these two data sets. And also we found a very low number of SNPs shared between plates. So we decided just analyze the whole information individually. So we have two different data sets to describe the individual's variation in Rancho Nuevo and Texas, and the second data set just for Texas individuals. After that, we analyze the mitogenomes. We recovered 22 mitochondrial genomes with a coverage between 28 to 2,382 X. We found 11 mitogenomes, all of them grouped in two different star groups, and being the H3 haplotype, just represented by samples from Tamaulipas and Veracruz. The second question, I want to say that in this study we identify SNPs with two different pipelines. We identify low coverage SNPs with the ddRAD-seq, and we know the most important, the most informative analysis was with the kempii genome, and also we found that only some positions were found in the resequenced genomes. The pipeline used for mitogenomes recovered 22 complete mitochondrial genomes and were identified 11 haplotypes. This information will be very useful for future strategies of conservation in the Kemp's ridley turtle. Thank you.